Hey, how's it going? My name is Ron Copper. I'm one of the instructors here at CAHI for the radiography program. I also teach the CAT scan registry review course and the MRI registry review course, which is what we're here to talk about today, MRI safety. So, just some things about MRI. We know it's a big machine. We know when we take our rotations through clinical, there's a possibility that we could come in contact with one of these big machines. We have to make sure that we stay safe, that we keep everybody else safe. Okay. So what is an MRI? There's a big magnet, that's what the M stands for. The R stands for resonance, we're not going to get into that. And then the I stands for imaging. The big magnet is what we need to talk about as far as safety. We're going to be using non-ionizing radiation. Up till this point, you've probably heard about all the ionizing radiation. Non-ionizing radiation that we use in MRI is actually in the form of a radio frequency wave. If you look around you right now, you'll see your classmates, some chairs, but you won't see anything just flowing through the air. What's flowing through the air, though, are radio waves. Like if you turn your radio to 101.1, that's a very specific frequency of a radio wave going through you at all times. Completely safe. What's not safe, this giant magnet that's going to be way stronger than the Earth's magnet. MRIs are measured in strength of Tesla, 1 Tesla, 1.5 Tesla, 3 Tesla, 0.5 Tesla. That's a measurement that tells you how strong a magnet is. A 1.5 Tesla magnet, though, is 21,000 times stronger than the Earth's magnetic pull. Okay. Anyone that goes into an MRI room is at risk and always needs to be screened. Everything that goes into the room needs to be screened. The magnet is always on. The magnet is always on. I'm going to say that one more time. The magnet is always on. That's how important it is. Anyone that goes in the room, the person that works the MRI machine, the technologist, the patient, anyone that's accompanying the technologist, anyone that's accompanying the patient, you as a student going into MRI, the housekeeping department, anyone. You want to think about it like a pool. You can't jump into a pool without getting wet. You can't go into an MRI room without being exposed to the external magnetic force. Okay. There's a very specific type of metal that's extra dangerous. It's got a magnetic dipole that's called ferromagnetic. I know that sounds confusing. Ferromagnetic, though, just means that we're going to be pulled very, very quickly into a magnet. It's dangerous. If you think about any jewelry that you're wearing, can you tell exactly what that's made of? If you can't, you don't want to maybe risk taking it into an MRI room because it could be ferromagnetic. Okay. When you walk around the MRI room, you're going to see all these different signs. We've got a green sign, a yellow sign, a red sign. They're very similar to if you drive. A green light, a red light, a yellow light. Green is going to stand for MRI safe, good to go. Yellow is going to stand for MRI conditional, which means that we may have to figure out exactly where we can take that device. And red stands for MRI unsafe. That means we should not take it into an MRI room at all. MRI departments are going to have these labels on everything, including chairs. You'll notice that chairs, fire extinguishers, everything will have one of these labels to let you know if it's safe to go in the room or if it really shouldn't go into the room. What happens when you take something into a room that shouldn't go into a room? You're going to have something like this. If we can see what this looks like, and I'll make sure we have a picture, any device that is magnetic will get pulled into the magnet. Now, this maybe looks like kind of a funny picture. Definitely is not, though. This is an extremely dangerous situation. We want to think there could be a patient somewhere here. This could be where someone's legs are. Okay. We want to think anything going into the MRI room as it gets closer to the center of the magnet is going to get pulled faster and faster and faster. I won't go into the details of that, but there's lots of inherent risks in taking anything that's ferromagnetic into an MRI room. The only way that we'd be able to get this device off of that magnet, there's 2 ways. One, you have a bunch of technicians come into a room, not the people that operate the machine, we're technologists, but you have a bunch of technicians that are going to operate machinery to use a crank to physically pull the device off the machine, or you have to do what's called a quench. And quenching the magnet is an explosive, dangerous, and extremely expensive event. Okay. On here we have $250,000 as a price for a quench. Not to mention that the MRI machine is going to be out of commission for a number of days. Plus there's other inherent risks. In a quench, what happens is these cryogens that are, we're not going to get into details, but the cryogens that are inside the magnet, they're liquids. One of them is liquid helium. Liquid helium is super cooled. When it's released, it can cause hypothermia for anyone that's in the room because it releases very quickly. It can also cause what's called anoxia. It's, again, if you think about a balloon that's filled with helium, it rises, it expands. You want to think that's the same thing that's going to happen when we go from a liquid to a solid. It's going to get rid of all the oxygen in the room, including the oxygen that's in your lungs. Okay, so is it safe? We want to think about that whenever we take anything into a room, including yourself. If you have anything inside of your body, anything on your body, any kind of jewelry, is it safe? If you don't know for sure, the answer is no, don't risk it. These were two situations where there were wheelchairs taken into an MRI room. It was not safe. We have some videos down here, I'll make sure we have access to those. But the magnet will pull anything metallic, anything that has any kind of what's called a metallic susceptibility into the machine itself. It can be very, very dangerous. This is called a projectile effect. What could be a projectile? Anything that's pulled by the magnet. We want to think, if we took any kind of metallic device and threw it, it would already be dangerous to begin with. In MRI, not only does it get pulled towards the magnet, but it's going to continuously ricochet, which creates a whole bunch of problems. You just don't forget. Okay, so any personnel that's entering the MRI suite is going to have to be free of any kind of devices that could be magnetic, could be pulled in. We'd want to think, don't walk into the room with scissors, because scissors will be flying around the room. We can already just imagine how dangerous that would be. Your jewelry, make sure your jewelry is not magnetic, doesn't have any kind of magnetic susceptibility. If you're not sure, just take it off, leave it outside, take it off, leave it in your locker, take it off, leave it in your car. Cell phones, credit cards, those type of things we do not want to take into the room. They do work by principles of some magnetic susceptibility components. If you take a credit card into an MRI room, it will no longer work. It's a magnetic strip, even in your chip, a magnetic chip, that's going to cause it to work. Credit card is destroyed, you have to get a new one. Also, things like scissors, as we just mentioned, and a stethoscope. We don't want anyone going into the room, just walking into the room with anything loose and metal. That includes doctors. This is your one chance to say to a doctor, hey doctor, stop, you have to take off that stethoscope, because it's a dangerous thing to take inside. Other things that we worry about, hairpins that we don't think about very often. Hairpins, paper clips, some pins, maybe chairs, floor buffers for if someone's working on the floors, IV poles. Remember, if a patient has an IV pole, we have to think, is it safe to bring this inside of the room? Oxygen tanks, fire extinguishers. Fire extinguishers and oxygen tanks are very important. One of the reasons why you have to take this MRI safety training is because of an event that happened here in New York involving an oxygen tank and it ended with the fatality of a pediatric patient. If you don't know what something's made of, don't take it into the room. Okay, now, patients, students, workers, anyone that goes into the MRI room should carry information about any implants that are inside of their body. You should know about any jewelry, piercings, tattoos, anything that might be on yourself that could cause an injury. If you're not sure about an implant, there's a website called MRISafety.com that'll give you lots of information, lots of background on very common implants. Manufacturers can also provide lots of information. So if you have an implant, you're worried about going in MRI, you don't know for sure, you can call the manufacturer if you remember what kind of device you have inside. Other things that we think about as possibly causing a problem, in most cases only if you're getting an MRI, would be tattoos, medication patches, wound dressings, and body piercings. And body piercings, we want to remember, if you're in a room getting an MRI, even if you don't feel your piercing getting pulled by the magnet, remember that when the MRI starts, any metal that's inside is going to superheat, so you definitely don't want that inside your body. Okay, there's lots of internal objects that could be inside of a patient, could be inside of yourself as a student, like neurostimulators, cochlear implants, bone growth stimulators, gastric reflex devices, stents, and vascular clips. We want to have lots of information on those things before we go into the room. Again, you're hearing lots of information about before you even get into the room because that's where the safety comes in handy. Okay, so we already talked about this idea of radio frequencies that are always just flowing through the air, through us, all the time, not affecting us. When we're inside of an MRI though, we want to be aware that the moving radio frequency that is going to be at a resonant frequency with the molecules that are in your body, a lot of big words, it's going to cause heating to happen. There's a lot of motion that's going on inside your body, a lot of friction at a molecular level. It's going to cause heating to happen at a certain point. We want to keep that in mind even if we're not getting an MRI ourselves. We want to be able to tell our patients that we understand that you're getting a little warmer and it's completely normal. Okay. What we do worry about though is if there's any wires like IV, like leads, EKG leads on the patient, we don't want any of those, any kind of medication patches because those could cause burns. Like I said, any metal inside the MRI while the MRI is happening could cause superheating. Okay. Now, some things to think about when you're in the room. You safely made it in the room, congratulations. Some things you want to think about though. A static magnetic field, we already talked about like a pool. Jumping inside of a pool is going to have some effects. You're going to get wet. It's going to be wet all over because you jumped inside of a pool. When you go inside of an MRI machine, if it's of a certain strength, a higher strength, there could be some biological effects associated that you might not notice at first. Some of them are going to include headaches, irritability, hypotension, and maybe even nausea. It's continuously walking through a magnet that's of a certain strength, usually over a 2 Tesla strength, is going to cause those. Something for you to think about if you're going in and out of the room. Something else that we want to think about if you're a patient, or if you're staying in the room with a patient, which I don't recommend, but if you have to, there's what's called acoustic noise. If you've ever had an MRI or ever seen an MRI, you're going to hear lots of banging, lots of clicks, lots of pops, maybe some laser sounds, wonderful sound effects. What that is the changing polarity of the magnet that happens so fast that it causes very, very loud noises. Those loud noises could be damaging to your ears. What we want to think about is we're putting someone into a giant speaker at a concert. Like at a concert, you're standing right next to the speaker. So for up to 45 minutes, you're just going to have sounds blasted at you from all directions, which could be very dangerous. For most MRIs, we try to make sure that our patients are wearing earplugs, wearing headphones. For you as a student, it's important that you're not in the room when you don't have to be, and if you are, you have ear protection. Very, very important. Something else to think about, if there's lots of noise, it could be difficult to communicate with your patient. Monitoring is an important part of MRI. Again, you'll have a technologist with you. There's always a button to press in case of an emergency for the patients, and there's always an intercom system for you to be able to talk to your patient. But remember, talking over a loud concert speaker, or even just outside, just in the city, could be difficult if there's a lot of noise. So all things to think about. I did congratulate you already for making it to the room, but I don't know where you've made it yet. There's all these different types of zones. There's a zone 1, 2, 3, and 4. Remember, there's no zone 0. There's no zone 0, that's not a thing. Starts at 1, okay? Zone 1 is going to be a freely accessible area. That's for the general public. We'd be thinking a hallway outside. We'd be thinking maybe even the parking lot. Anyone can go there, not a thing. We'd be thinking Zone 2 is going to be supervised by MRI staff. There's 2 levels of MRI staff, MRI level 1, MRI level 2. 2 would be the higher trained level. That would be the technologist. But this zone, zone number 2, is more for screening. It's for getting your medical history. That would be our front desk where you're checking in, you're filling out paperwork. Again, you fill out paperwork, a screening form to make sure 1, you're supposed to be there. 2, that it's safe for you to go inside. And that brings us to 3. That would be zone 3. It's a very restricted area. You have to be accompanied by MRI staff, whether it's level 1 or 2, into this area. These areas are locked. There's some kind of gatekeeper that's going to keep anyone from going into that area that doesn't need to be there. This is where we want to make sure we stop any kind of objects that could be dangerous from going into the next zone, into the actual MRI room. This is where we'll see a control room for technologists. We'll see changing rooms for patients in a little separated kind of area. before they make it to zone 4. Zone 4 is the actual magnet itself, the scanner. Zone 4, again, you have to be accompanied by a technologist. Make sure you make a technologist aware of anything that you're bringing into a room or anytime you're bringing a patient into the room, because this is one of the few modalities. Just walking into the room could be dangerous, could be deadly. And it's a very big department. Again, many of the rooms are going to be locked. It's going to be gatekeepers to make sure you don't go into the wrong areas. But you want to know what zone are you in, what zone can you go to, and at what point do you maybe want to make sure that you're with somebody that you know is going to keep you safe, or that you're going to keep somebody else safe. Okay. There'll be lots of signs in the MRI department. Again, we go by that same green, yellow, red to let you know everything's good. Maybe take some caution and oh no, stop. Just like for driving. Zone 1, Zone 2, Zone 3, Zone 4. Lots of these signs exist all around the MRI department. They have to follow those signs, definitely. Again, color coding helps let us know what's safe, what's not safe. Something else that's going to keep you safe is a screening form. I believe you're all going to have to fill out screening forms to make sure it's safe for all of you to go into the MRI department in general. If you have any devices, maybe like a pacemaker, it might not be advisable for you to go in. But there's a screening form. That screening form is not enough, and MRI technologists will also go over that form with you to make sure you filled it out correctly. If you're not 100% sure, they're metal detectors, but remember the metal detector only tells you if there is metal. It doesn't tell you what kind of metal. And if you aren't sure if there's anything else going on, you could feel your pockets. There's sometimes technologists, they'll make sure nothing's inside of somebody's pockets to make sure everything stays safe. Either way, MRI, very fascinating modality. We can see lots of things. If we went over the physics, it's amazing. You can see so many pathologies as they're going on, sometimes before they even go on. And if you have any questions, feel free to contact me or any of the staff members. We'd be happy to answer any of your questions. Contact your MRI technologist. But either way, have a fun time. Congratulations, and thank you for listening. Awesome.